Making a choropleth map with React and D3. Our goal is to reproduce this choropleth map based on this dataset. This missing migrants on a map visualization is pretty similar to what we want to do in that it loads a background map and it also loads data from a CSV file and visualizes that. Therefore, I'm going to start our choropleth map by forking this visualization. And then I'll rename it to be called HIV/AIDS choropleth map. The first code change I'll make is to make it load our HIV data. Over in useData.js, I can just change this CSV URL to be the raw URL of our dataset. I'll copy this one here, go back to our code, and paste it as our CSV URL. Now we need to update our row parsing function. I'm going to delete this outdated location coordinates parsing. And instead of parsing total dead and missing, we need to be parsing prevalence-HIV/AIDS, this big long string. So I'll copy this from the CSV file, and then I'll paste it here. And just to make our downstream code easier to work with, I'm going to make a new property called d.aids, just so we don't have to deal with this big long string ever again. We can check to see if this worked by saying if data console.log data. And in the console, we've got this array of objects, each of which has an AIDS property. And a year. See, here's one for 1990 and then another one for 1991. This is kind of problematic because a choropleth map can only show a single year. We've got a mismatch where our data contains values for multiple years for any given country, but the map, a choropleth map, can only show the values from a single year at any given time. So how do we reconcile these differences? Well, I think we just need to pick 1 year to show on the map for now. Maybe later we could add like a time slider or something like that, but the first pass will just show a single year. So the question is, which year should that be? If you look at the CSV file, you can see that it goes from year 1990 up until year 2017. Since that's the most recent, I think we should just show the data for 2017 on our map. But how do we do that? Well, we could use JavaScript arrays built-in .filter method to exclude all the rows that are not for the year 2017. But in terms of the code, where do we put that filtering logic? We could put it in useData and have useData just return that array that only has that 1 year. Or we could introduce a new separate piece of logic to deal exclusively with the filtering. Which is better? Considering we want to develop flexible code that works for our case now of showing a single year, but would also work later on if we wanted to dynamically change that year with a time slider, I like to think of the single responsibility principle. The single responsibility principle is a computer programming principle that states that every module, class, or function should have a responsibility over a single part of the functionality provided by the software. And that responsibility should be entirely encapsulated by the class, module, or function. We can apply this principle to our situation by introducing a separate module to do the filtering. That way, useData will be responsible just for loading in the raw data. And then there can be some other chunk of code just responsible for doing the filtering. That's how we can apply the single responsibility principle. All right, so back in our code, useData is doing its thing. It's doing the right thing. So I'll delete that console.log statement, and then I'll go over to index.js, where we can introduce something that computes the filtered data. If the data does exist, we can compute filtered data and set that equal to data.filter, pass a function that takes as input one row, d, and this function should return true if d.year is equal to the selected year, which is not defined anywhere, so I can just define selected year to be 2017. Now let's console.log the filtered data and see what we see. Now this array only has 231 entries, and each of these entries is for year 2017. Now we're in a situation where each row represents a different country. All right, we've got our data in place. Now let's investigate that code that is drawing the map to see what needs to change there to make it into a choropleth map. After our code that sets up the filtered data, there's a bunch of logic to set up a size scale and a size value accessor. But in the case of a choropleth map, we're not going to use size, we're going to use color instead. So at this point, I think I'll just change size to color. First, I'll comment out this console.log statement, and then I'll define size value to return d.aids, which we created in our data parsing logic. Max radius we don't need anymore, so I'll delete that. And then I'll rename size value to color value. And instead of size scale, let's create color scale. But what kind of scale will this be? The way I'd like to set this up is have it be sort of a continuous color ramp. To accomplish that, we can use D3's Sequential Scales. In the D3 scale package, one type of scale it provides is the sequential scale. With sequential scales, the output range is typically specified as an interpolator rather than an array of values. The D3 scale chromatic package provides a bunch of these interpolators that you can use, such as D3.scheme blues, scheme greens, grays, oranges, purples, interpolate turbo, interpolate viridis, interpolate inferno. There are a ton of these available. Since our goal is to reproduce this choropleth or something like it, I'm going to choose an interpolator that's kind of similar to this one. This one here looks pretty similar, D3.scheme YLORRD for yellow, orange, red. To use this, we need to import scheme yellow, orange, red and scale sequential from D3. And then our color scale can be an instance of scale sequential. And with sequential scales, instead of passing a range, we need to pass the interpolator into the constructor, like this. That's how you can set up a sequential scale. The max here uses size value, so I'll have to change that to color value. Now, when we render our marks, instead of passing size scale, we can pass color scale, and instead of size value, we can pass color value. All right, now we need to start making changes to marks.js. In marks.js, first of all, we need to take as input color scale and color value. And then what changes do we need to make down here? Well, first of all, this whole segment that renders circles for each data element, we can just delete because we're not making circles anymore. Instead, we're going to set the fill of these paths. This code renders one huge path for all land. Instead, we need to render many paths, one for each country. Instead of land.features.map, this should be countries.features.map. And countries, we need to get access to from what gets passed in as World Atlas instead of land. So I'm going to replace land here with countries. But where does this World Atlas come from? Well, over in index.js, World Atlas is just World Atlas, which comes from use World Atlas, which is defined in useWorldAtlas.js. And in this file, we have access to countries here, but it's not getting exposed when we call setData. Instead of extracting a feature from the topo.json for land, I'm going to extract it from countries and then assign that to the key countries in this object. Now we are actually rendering different paths for different countries. Back in marks.js, we're setting class name to be land, which I don't think we need anymore. I'm just going to get rid of that. And in styles.css, I'm going to get rid of the land style, which just sets the fill. For that matter, we don't even need this .marks style anymore. Now all of our polygons are black. Alright, so when we're making these paths, one for each country, we're going to want to set the fill of each one of these to be color scale of color value of D. But D is something we don't have. All we have is the feature. And what is this feature anyway? I'm going to convert this to a function with a body and return this path explicitly so that I can say console.log feature. Here's our feature object. It has a geometry which is used to render the polygon, but it also has a property called properties with another property inside of that called name that gives us the country name, for example, Zimbabwe. Therefore, we could log out feature.properties.name and then get Zimbabwe. All right, we've got the country name for each country, and from there we need to look up what I'm referring to as D, the original row from the table that matches up to that country. But how do we do that? Well, if I were to do it manually, I could just hit Control F and type in Zimbabwe, and then look up the value for 2017 and find out that this is the number, and then pass in that number to our color scale. To do this programmatically, we need to introduce some kind of a lookup table where we can give it the country name and it will give us back the row from the table that corresponds to that country name. One way we can do this is by using an ES6 map data structure. A map holds key value pairs. You can construct a map by saying new map. You can then call map.set key and value, and then later on you can call map.get, passing in a key to retrieve the associated value. Let's use this map data structure to set up a lookup table where the keys are country names and the values are the rows from the original data table that correspond to those countries. This lookup table is the missing link that we need to go from country name to D, the row from the table. Let's assign D to be row by country dot get feature.properties.name. Now our task is to set up the row by country map. This is something we can pass in from the outside instead of data. So now over in index.js, when we render our marks, we should pass in row by country equals row by country. And now let's define row by country, which will be derived from our filtered data. I'll define row by country to be a new map. And then for each row of our filtered data, called D, we can call row by country.set. The first argument will be the country name. Looking at our CSV data, that's going to be a property called entity. So the key will be d.entity, and the value will be D itself, the row itself. Now let's take a look at row by country, console.log row by country. We get this map instance where the keys are country names and the values are the original rows from the table. All right, so far so good. Things should be working. I'll get rid of this console.log statement. And nothing is showing, so now it's a matter of debugging what's going on. We get an error that says U is not a function at marks.js line 19. Here's line 19. It's the one that sets the fill using the color value of D. Let's just console.log various things to make sure that everything we need is in place. First, I'll console.log D. We see the object, the original row for Zimbabwe, so that looks good. Now let's console.log color value of D. That gives us the number 13. That looks pretty good. Now let's console.log color scale of color value of D. It looks like that is not working. So what if I just console.log color scale? It does look like a function. I'm not really sure what the problem is. I wonder if there's something wrong with how we set up the color scale. I'm going to go back to index.js, and I want to make sure that this scheme was imported correctly from D3. So I'm going to say console.log this scheme here. Oh, it's an array of arrays. You know, I don't think this is the right thing. Yeah, we need to use an interpolator, not this scheme. Let's go back to the documentation. Instead of using scheme yellow, orange, red, I should have used interpolate yellow, orange, red. If it starts with scheme, it's the discrete version that has, sets of discrete different colors, whereas what we want is the interpolator, the continuous version of the color ramp. All right, I'll get rid of my console.log and change scheme yellow, orange, red to interpolate yellow, orange, red. And then when we set up our color scale, I'll pass that in. Now we get another error, cannot read property aids of undefined. This suggests to me that some country names don't match up with the country names in the data, or maybe there's missing data for certain countries. In the case that there is no row, in the case that D is not defined, what should we do? Should we just not render that country, just leave it empty hole? Or maybe we should render it a special color that represents missing data? I kind of like that approach. In that case, we can say, is there D? If so, use the color scale. Otherwise, use the missing data color. And that missing data color I can define up here to be, I don't know, let's use red for now. All right, we get some colors, but red may not be the best choice because the color scale has red in it. So how about, let's use gray as the missing data color. Okay, now it's more clear. All right, we're getting pretty close. I suspect at this point it's just a matter of the names not exactly matching. Let's figure out which countries have missing data and then see if there is actually data in the data set for that country using a slightly different name. And if there is, we can make them match up somehow. In the code, I'd like to know which countries are missing. So here I can say if there is no row for the given country, then console.log feature.properties.name. All right, we've got a list of all the countries whose names don't match. Vatican, Micronesia, Marshall Islands, U.S. Virgin Islands, United States of America. There are actually quite a bit of mismatches here. My original thought was, well, there might be a couple that don't match and we can just sort of fudge it to work, but I don't want to be fudging so many mismatched names. Perhaps a better approach would be to use codes instead of names. But what codes do we have available? In our CSV data, there is a row called code, and we get values like AFG, ALB, ARM, but what are these codes? I'm pretty sure these are ISO 3166 country codes. ISO stands for International Organization for Standardization. These codes look like AFG, ALA, ALB. These are the Alpha 3 codes. All right, these are the codes we have in our AIDS data. What about the topo.json? Well, in the World Atlas Project documentation, we see that for world.objects.countries, each country exposes country.id. the 3-digit ISO 3166 numeric country codes. All right, so we've got the numeric codes from the topo.json, and we've got the 3-letter codes from the AIDS data. There is a one-to-one correspondence to these codes, and I think we're going to have to find a data set that represents that correspondence and pull in that data set so that we can make these data sets work together and resolve the numeric ID to the 3-letter ID. But how do we do that? I mean, where does that table come from? Well, here's a table right here in Wikipedia that says for the alpha 3 code AFG, that corresponds to the numeric code 004. Ideally, we could get this table into CSV format. I wonder if such a CSV exists already. I guess I'll just have to dig for it. I just did a Google search for ISO 3166-1 CSV, and it looks like there's a CSV right here. This looks like a pretty well-maintained project. It says these lists are the result of merging data from 2 sources, the Wikipedia article and also the UN statistics site. It says here 3 versions exist for each format: All, Slim 2, and Slim 3, which just has the English name, numeric country code, and alpha 3 code. It looks like Slim 3 is what we need. Under the Slim 3 directory, we've got slim3.csv, which weighs only 5 kilobytes, and it's got what we need, alpha 3 and the country code. I can just use the raw URL for this CSV file. I'll copy this URL, and back in our code, we need to introduce another piece of logic or another module that will actually load in this CSV file. UseData is already doing something very similar. So I think what I'll do is I'll make a new file called usecodes.js, and then I'll copy all the logic from UseData into usecodes. And then I'll change the CSV URL to that URL that I had copied earlier. And with this data, we really don't need any parsing function because we're just dealing with strings. So I'll delete references to our row function. And I'll rename this export to usecodes. All right, now in index.js, we can import usecodes from /usecodes. And in addition to useData, we can invoke useCodes and then assign that value to a variable called codes. And if there are no codes, then let's display the loading indicator. To check if this is working, I'm going to say console.log codes. All right, this looks good. Each object has alpha 3, country code, and name. All right, now that we've got this in hand, we need to connect all the dots. Now that we're going to use codes, this whole concept comes into question. Do we really want row by country? Well, we need row by something, and that something that we have from the topo.json data for each country is the numeric code. So I think I'll rename this to be row by numeric code. And then as we iterate through the filtered data, we're going to set on row by numeric code the value of D, the row, but the key, instead of being D.entity, it's going to be the numeric code. And numeric code is something we need to derive from D. And keep in mind, D is one row from our CSV data about AIDS, which has a column called code that resolves to these alpha 3 codes. So I can say d.code, but this is not numeric code. This is the alpha 3 code. So how do we get from alpha 3 code to numeric code? We need to somehow define numeric code as a function of the alpha 3 code. Well, I think we need to set up a new lookup table where the keys are alpha-3 codes and the values are numeric codes. Assuming we had such a map, and it were called numeric code by alpha code, we could invoke .get, passing in the alpha-3 code in order to retrieve the corresponding numeric code. Now we need to assemble this lookup table. So let's do that right here. Let's say const numeric code by alpha code equals new map, and then for each code we can invoke numeric code by alpha code dot set, where the key will be alpha-3 code and the value will be numeric code. Now we need to define alpha-3 code based on code, and I don't remember the structure of this, so let's take a look at the console to see what each of these code objects looks like. Alright, the columns include alpha-3 and country-code, which I'm going to copy because we can use those to extract the values. So alpha-3 code will be code at the property name alpha-3, and then numeric code will be code at the property country-code. Now this numeric code by alpha code map should be set up. To verify that, let me just say console.log numeric code by alpha code. This looks good. It's a map that maps the alpha codes to numeric codes. Great. Now let's check if the downstream code is working. Did this thing get set up row by numeric code? Let's find out by saying console.log row by numeric code. This looks pretty good too. The key is the numeric code and the value is the original row from our table. All right, all we need to do now is to modify our marks rendering logic to take advantage of this new lookup table. Now that we've got row by numeric code, we can pass this into our marks, which was previously expecting row by country. So I'll change that to row by numeric code. And then over in marks.js, we can unpack row by numeric code. And then in our rendering logic, instead of using row by country, we can say row by numeric code. And I believe it was available at feature.id. All right, now we get a map that actually looks somewhat complete. All right, that's how you can make a choropleth map with React and D3.